This conference will now be recorded.
Okay, students, we will start the class. Time is over. So, in today's class, we are going to discuss about load scheduling among the two units or two plants. See, the same method we did the problems in first unit, but the procedure is different than compared to this. So there we use the formulas, but here we use that data. Based on that, we can form that how we can schedule that these two plants. So this is the today's topic, that is problems on load sharing. So let me see how it will be, how we can find that load sharing among the two plants from the given data. See here, this is the question. The given the two 750 kilowatt alternators operate in parallel. The speed regulation of one set 100 to 103% from full load to no load. Sorry, it is M. And from full load to no load, and other of and that of other is 100 to 104. How will the two alternators share the load 1000 kilowatts? So based on this, so if we have the two generators, that is two alternators, let consider it is A and B, and each alternator having the capacity is 750 kilowatts. And by using these two alternators, the load should be the load requirement is 1000 kilowatt. But what is the, how we can find that, how sharing between these two alternators? Now from the given data, so this is the two generators are operating in parallel, and they have to be sharing the load equally. That is a shared part. And here one of the alternator is drooping is 3%, another one has the 4%. Let me take, so generator A has that drooping is 103, so it consider it is 103, and generator B has drooping is 4%, then you will have 104%. Now the capacity of each one is 750 kilowatts. Right? Now, what is the sharing between these two? So let's consider based on this two sharing, that is 1000 kilowatt. Right. So now we have to find that from the given data. This is the way of categorizing it. So we have the two alternators A and B, and each operating on parallel condition. And one set is having the drooping is 100 to 103%, and another one is drooping is 104%. Now from this data, we have to find that how the scheduling happening between the PG1 and PG2 while delivering the 1000 kilowatts. Now let's consider it is a point 100, and in this point we have to share the load. And so we have 100%, 103%, and 104%. So at 100% we want to find the sharing of the load. Now let's consider this portion is this among this portion from here to here. This is the portion generated by the X, and it is, no, it is 1000 minus X. So after sharing that, X is generated by the PG1. So PG1 is equals to X, and PG2 is 1000 minus X. Right? This have to, we have to define it. Now, so let's consider points A. It is B, C, D, E, F, G, and H. So first of all, we have to make the graph like this from the given data, right? So are you clear about this? Now from this diagram, what we can do means we have to calculate that what is the sharing of A and what is the sharing of B. Now, if you observe this diagram, we have them four equilateral triangles. The four triangles. Let me see what are the triangles. First of all, the triangle BCE and the triangle BAE. So BCF and BAE. So first one is BCF. This is the one triangle, and BAE. So this is the other triangle. Now from this equation we can calculate how it is. So from the equilateral from the triangle of BCF and BAE, we can write CF divided by AE equals to BE divided by BF divided by BE. So here let me take that the total height is H. Next, what is the value of BC here? BF. What is the distance between FB? So if it is total height is H, then from here to from top to here it is 4 minus H. From here to here it is 3 minus H. Right? So instead of CF we can write. So what is the distance of CF? So this is the distance, right? So instead of CF we can write X divided by what is the value of AE? Distance of AE 750 equals to what is the distance between FB? 3 minus H divided by what is the distance between BE? BE. So 3 minus H plus H, that is 3. So find the X equation from here by solving this equation. Find the X value, X in terms of H. So if you solve this equation, you will get that equation in terms of X equation in terms of H is 750 minus 250H. So this is the what we got the X value. X is equals to 750 minus 250H. So now we have to derive that another one. So we found the value of X, that is X equals to 750 minus 250H. So I will draw the diagram neatly. Wait. So it is PG1. It is PG2. it is. So let I consider the points here. So after consideration of, we have to form this. So the generation between this 750 kilowatts, here 750 kilowatts. So this is the each individual capacity. And by using these two generators, we have to schedule that for 1,000 kilowatts. So it is H. From here to here, it is 3 minus H. From point A to point B, it is 4 minus H. And here the generation given generated by the PG1 is X, and the generation generated by PG2 is 1,000 minus X. So just note down this diagram. So if you observe this diagram, so this was obtained from the given data. So we have the two alternators PG1 PG2, both are running at parallel condition, and both having the capacity is 750 kilowatts, 750 kilowatts, and they have to be shared 1,000 kilowatts. And here the points, the first generator having that 100 to 103. So this is the point we can take, we can get that. So here we are getting 104 percentage. One or 3%, 100%. See, in problem they given the speed regulation of one set is 100 to 103%. It means that the PG1 is increased to that 100 to 103, and PG2 is increased to that 100 to 104%. Now, from this diagram, we have to find that what is the sharing of PG1 and PG2. Now, if you observe this PG1 part, that is half of the part, this one, we have the triangles from. So we have to solve this equation in two cases. So from triangle BCE and triangle BDF. So from these two triangles, we have to form the one equation. Similarly, from AEC, from AFC, we have to find the other form. So let me see case one. So from this diagram, from this triangle, we can write like this. So first of all, in this BCE and BDF, from these two triangles, we can write the equation CE divided by DF equals to BE divided by FB. Right? What is the value of CE here? X. X divided by, and DF is 750. 750 equals to, what is the BE value here? 3 minus H divided by, what is the total value, that is from B to F, that is the distance between FB is 3 minus H plus H, so we will get H value. Now if you simplify this equation, we will get X equals to 750 minus 250H. So replied it is equation 1. Now similarly, we have to solve the second equation by using from triangle AEG and triangle AFH in a similar manner, right? So how we can write means EG divided by FH equals to, so EG means that is a parallel lines, EG and the FH divided equals to under straight lines, AE divided by AF. If you what is the value of EG here? 1000 minus H. 1000 minus H divided by, what is the FH value here? 750 equals to AE. The distance between A and E is 4 minus H divided by the distance between AF. What is the value of AF? 4. 4 minus H plus H. Total distance is 4. Now simplify this equation. 1000 minus H divided by 750 equals to 4 minus H divided by 4. So after simplification, you will get X equals to 250 plus 187.5 H. So this is equation 2. Now equating 1 and 2, then find the value of H. So by equating 1 and 2, then find the value of H here. Find the value of H here. What is the value of H? So we have to think height. So that is the different, the start, the point which was a greater value. So height and distance from I assume just call height అనేది. So we have to find the H value. So the H value is 1.14. So they only give the data. They only giving the data. What is the capacity of generators and what is the speed regulation? Based on that, we have to find that the distance, that is height, height and distance formula on the vidhanga. Okay. So here, if you want to find the H value, then only we can find that X. That is the generation by 1 and 2. So ఇక్కడ H అనేది not for total. So this is for weight actually. So this was the distance between from here to here. So this is H from AF. So from AF, EF is H. From DE is 3 minus H, and for A is 4H. 4 minus H. So now I think you're clear, right? So from the height is given by that, the regulation, the 100% regulation of the two generators. So here the H value is 1.14. Now substitute H value in equation 1. Substitute the H value in equation 1. That is X equals to 750 minus 250H. What you will get? $464.25, right? So so one generator capacity is scheduling is 464.25. What about other generator 2 capacity schedule? So the generator 2 capacity is 1000 minus 464.25. So you will get 535.75 kilowatts. So this is the way of finding that load scheduling by using the data without using any formula. So we will do one more problem, then you will get clarity on this. See here, so listen carefully, then only you can understand the problem. From the given data, what they given, the two generators rated at 120 megawatts. So each generating one generator is having that 120 megawatt, and the second one is having that 250 megawatt, and these two are operating in parallel. The governor setting on the machine are such that they have a 4% and 3% drops. Determine the load taken by each machine for a total load 300 megawatt. So మనకు two generators ఇచ్చారు. సో ఒక generator capacity 120 megawatt, second generator capacity 250 megawatt, and the first generator having that 4% and second generator having that 3% drops in the regulation. Now we have to find that For obtaining the load demand through 200 megawatt, what is the load sharing between these two? So just again I'm drawing the model here. So let's consider two generators. This is PG1 and here PG2. And here the first one is having the 4% of looping, so we have to draw a line. So let's consider a center point, that is the capacity for these two. Right. So here this is 104%. And here 103. So the capacity between these two is one is 120 megawatt, another one is 250 megawatt. Now at 100%, let me see what is its value. Let's consider it is the 100% line. Now it is X and it is 200 minus X. From here to here, height is H. From here to here, height is 3 minus H. From here to here, it is 4 minus H. So now let us assume the points A, B, C, D, E, F, G, H. So this is the diagram what we obtained from this question. So we have the two generators. One is 120 megawatt, another one is 250 megawatt. For this, we have what we have to find means we have to find the load sharing among these two generators, that is given by 200. Okay, now. So I will draw this here. You can get easily. So this is the graph we obtained here. Now, by using these triangles, we have the two sides, right? So one is generated one side and generated two sides. By using these triangles, then we can find that h. After that, we can substitute that h value, x value. Then we can find what is the load sharing for PG1, what is the load sharing for PG2 out of 200. Now let me see the first one is first triangle on this side. The BE divided by CF equals to, next what will get AE divided by AF. So what is the value of BE here? X divided by what is the value of CF? 130 equals to AE. What is the value of AE? 4 minus H. What is the value of AF? 4 minus H plus H. So totally we will get 4. Now from this equation, the value of the equation of H will get, what you will get? 4x equals to 480 minus 120H. So 120H, 120 minus 30H. This is equation 1. And this entire part is for generator 1. For generator 2, we have EG divided by FH equals to AE divided by AF. Sorry, AE is not DE. DE divided by DF. Because from here to we have to calculate EG divided by FH, DE divided by IEF. So what is the value of EG? 200 minus X divided by, what is the value of FH here? 250. 250 equals to, what is the value of DE? 3 minus H. And DF, that is 3 minus H plus H. So you will get 3. So from this, by solving this equation, you will get X equals to what you will get equation here? (250H) divided by 3 minus 150 divided by 3. By solving the equation 1 and 2, find the H value. So equation 1 is X equals to 120 minus 3H. So second equation is 120 on 250 by 3. What you will get? 250 by 3. 83.33. 83.33 H minus 50. This is equation 2. Simplify this equation 1 and 2, then find the value of X. Equating this 1 and 2. Find the value of H. What is the value of H, students? 120 minus H equals to 83.33 H 50. Right, 1.5. Then substitute in H value in equation 1. Substitute 1.5, that is H value in equation 1. What you will get H value? H value. $75, right? So 75 is what? What represents 75? Not. So the 75 is we got X equals to 75, right? So this is the portion of 75. It means that 75 is the power generated by the PG1. So next, out of 200, 75 is power generated by the power 1, and remaining 125 is generated by the 2. Okay now. So this is about problems is based on that load sharing. So మీకు load sharing అనేది different ways లో చేయొచ్చు. So we can use, so based on the given data and based on the conditions, we can use what we discussed in the first unit. So we can use that formulas, or else we can use this method also. Okay now. So మీకు second unit నుంచి problem కనుక అడిగితే you may get problems in this manner. Okay now. So you have to prepare the graph like this, and from the graph we can use that triangle data waveform. Then we can find what is the load shedding among the two units. Okay now. So we will see that what are the questions asked from the second unit in external exam. So this is about two problems we solved in this class. So మీకు ఇంకా రిమైనింగ్ ప్రాబ్లమ్స్ ఉన్నాయి, అవి మెటీరియల్స్ ఉన్నాయి, ప్రాక్టీస్ చేసుకోండి. So now we will show you, I will show you that what are the previous questions asked in external exam. So the power generation by 1 is 75. See here, so most probably you may get derivations. One is from hydrothermal scheduling, another one is like speed governing system. Okay now. So based on the second unit, I'm going to conduct the exam on tomorrow. Okay now. So tomorrow we have a slip test too. After that we will start the third unit. So మీకు థర్డ్ యూనిట్ అర్థం అవ్వాలంటే, if you want to learn the third unit, then you have to be aware about what is the speed governing model. Okay now, speed governing model మీకు తెలిస్తే, that is block diagram. It is very easy to study the third unit. So మీకు థర్డ్ యూనిట్ ఈజీగా ఉండాలంటే you should have to know that what is the block diagram of speed governing system. ఓకేనా, బ్లాక్ డయాగ్రామ్ కనుక తెలిస్తే మీకు థర్డ్ యూనిట్ ఈజీగా ఉంటుంది. If you don't know the block diagram, then it is difficult to study that third unit. So students, have you got these values, PG1, PG2? Right, let me see there is any problem asked from the second unit. So ఏమైనా ప్రాబ్లం అడిగా చూద్దాం సార్ ప్రీవియస్ క్వశ్చన్ పేపర్స్ లో. So most probably they are asking that only 3 questions. See here, the hydrothermal scheduling and mathematical model of fluid governing system. So we have to derive the block diagram for this question. Now let me see one more question paper. So here also the same. Derive the model of fluid governing system and represent this block diagram and explain about solution of pumped storage hydrothermal scheduling with iteration method. So this is the same questions in this paper also. You see one more question paper. Here describe the hydrothermal scheduling. Derive the transfer function model of reheat type of steam turbine. So here we have to derive that turbine model. So one is speed governing until turbine model we have to derive. So what they ask, derive the transfer function model of a reheat type of steam turbine. Okay now. So until a turbine, so there is no need to derive the generator model here. Right. So ఇక్కడ ఇచ్చే చూడండి 2 generators rated at, okay now. So see 2 generators rated at 100 megawatt and 200 megawatt are operating in parallel. The troop characteristics of their governors from no load to full load are 4% to 5% respectively. Assuming the generators are operating at 50 Hz at no load condition, how the load of 300 megawatt be shared between the generators? Okay now. So here in this paper they asked the problem what we discussed now. So try to do this problem. Two generators rated, just based on the question, draw the graph. That is, draw the triangles. It's like a height and distance. So let me see that how it will be. I will draw here. We have the 2 generators at both ends. So generator 1 and generator 2. First generator having the 4. So first highest point is 5%. That is for generator 2, and second part is 4%, that is generator 1. So here 105% and here 104%. The individual capacity is 100 megawatt and 200 megawatt, and they have to be shared the load between, total load is 300 megawatt. And from here to here h, this is the distance of h, and it is 4 minus h, and it is 5 minus h. So by same way what we discussed now, so do this problem like this. And second question what they asked means also find the sharing if the both generator having the same troop. So for this what you will get, you will get a triangle like this. Here 4. Okay now. So for this problem, solve the problem and send me the answer. Okay now. So okay students, this is about today's class, and we prepare for the tomorrow exam. And so the same questions I will ask them what we discussed in second unit, and after that we will start the third unit. Okay, now I'm going to end the class. So if problem మీరు solve చేసి నాకు సెండ్ చేయండి. ఓకేనా, ఆల్రెడీ ఈ ప్రాబ్లం మీకు ప్రీవియస్ క్వశ్చన్ పేపర్స్ మీకు ఆల్రెడీ గూగుల్ క్లాస్ రూమ్స్ సెండ్ చేశాను. ఓకేనా, అండ్ లెట్ మీ సీ దిస్ పేపర్ ఇస్ బిలాంగ్స్ టు R9 రెగ్యులేషన్. ఓకేనా, సో ఈ ప్రాబ్లం చేసి నాకు సెండ్ చేయండి ఆన్సర్. రైట్, సో దిస్ ఇస్ అబౌట్ టుడేస్ క్లాస్. I'm going to end this class now. Thank you.